My name is Greg Guak. I'd worked for Diversified Biotech, but I am the Planet Safe guy. 100% what I've been doing the last few years is focused on Planet Safe. So to start, we make Planet Safe out of PLA or polylactic acid. And for the scientists in the room, maybe I don't have to say this, but what is it? It is a resin made specifically in our case for sugarcane. So the sugarcane is processed, it's crushed, the resulting juice is then purified, it's catalyzed, and then is polymerized, extruded into resin. We make it into Labware. So pharma and biotech waste, I always use the number 5.5 million metric tons annually between biotech and pharma. That's the plastic waste number. That's the amount of waste that's being created. It doesn't mean much to me. So what I like to do is to put it in real world terms. That's 55 large cruise ships. Not the small ones, not the ones that I want to take that go down the Rhine and stop at all the cool cities and villages in Germany, the big ones. I just went to Italy a few weeks ago and spent some time in Paris. So that's 753 Eiffel Towers of plastic waste that's being generated and disposed of between biotech and pharma annually. It's also almost 917,000 elephants. So that's what's getting, that's the single-use plastic that's getting disposed of during research over the course of the year globally. And of course, there's costs to that. So as a single-use item, it's just continually depleting the fossil resources that we do have. The process of acquiring those inputs is very toxic. It's not the kind of thing that you want to live by. The greenhouse gas emissions, when inevitably 80% of our customers are incinerated, those that are generated during the incineration process, those are costs that people sometimes don't think about. And then the loss of material. If you're in a situation or a position where you need, as biohazardous waste, to incinerate that product, there's no opportunity to get it into the circularity, into the system to be reused. That material is just essentially, you pay for it and the value is gone immediately. There's also hidden costs that kind of go hand in hand with the costs that we do tend to think about. So someone has to make this stuff, right? Someone has to make the rest. Someone has to extract the fossil resource. And that's hazardous, right? So there's worker exposure that you need to be concerned about. Again, this isn't the kind of thing that you want to live by. So there is a community impact in terms of equity that there are concerns. Additionally, the environmental justice concerns, right? Again, how is the acquisition of the raw materials, the processing into a resin, how is that affecting surrounding communities? So in choosing PLA, the macro decision was easy. What is the material that is sustainable, that is plant-based, that we can use, that will be around in the next 1 or 2 years and beyond, right? We don't want to know that there is a lab somewhere that can make something we can use out of seaweed if they can only make, 1,000 pounds at a time, let's say. So specifically with PLA, there's several different feedstocks that can be used to create the resin. Corn, sugar beets, sugarcane, these are the most popular ones. Corn has its issues, of course, because if you're using corn to make the resin, you're taking that corn, you're diverting it away from that's food for people, right? So that's food for people. Additionally, it can be food for livestock. If you're talking about, processing into, cans of corn and you've got the waste, that can be used for livestock. So you'd be taking that away from more important sources. Sugarcane, when you talk about creating the material, is 35% more efficient to process than a sugar beet or corn. That means that per hectare of material, a plant, you're getting more resin than you would with the other inputs. Our partner, Total Energies Corbion, is an excellent partner. One of the reasons is because they have excellent byproduct utilization. When we talk about things like fertilizer, during the processing of the sugarcane, a lot of those byproducts are being reused. They don't take any energy from the grid to run their processing. They actually do all that on site. So they have an excellent waste to energy component that actually generates enough energy that they can make their material and sell some of it back to the grid. From the feedstock side, equitability. I talked about our partner, Pole Energy's Corbion. They're visionary, right? So they are thinking about what is the role of PLA now? How can we make it more useful? And then down the line. So one of the things that they pioneered is advanced recycler, which is essentially taking the PLA, the products that their PLA makes, and hydrolyzing them, breaking them down to the monolith, building them back up. And what you have is you have a material that doesn't lose any of the characteristics. Very important to their equitability aspect is third-party verification. So to my knowledge, in the petroleum industry, when you're making things like polystyrene resin, there's no one that's going to come in and do what Fair Trade Coffee Pro did. Make sure that the workers are being treated fairly, make sure that they're operating in a safe working environment. That's something that Pole Energy's Corbion is very dedicated to. So the sugarcane that they use to make the material only comes from Bone Supro certified plantations. So Bone Supro, third-party organization, they go in and actually audit the plantations to do things I said, which is to make sure that the workers are being treated fairly and that they're operating in a safe working environment. That's a commitment that they've made. And the reason that's important is because this is aspect to sustainability that a lot of people don't think about at the face value. I always say you can't call sustainability without equitability. So it's important now as we move forward to ask those hard questions. Yes, this whatever it is plant-based, but where did it come from? It's PLA. Okay, well, where did that come from? A lot of people will ask me, why don't you just use PLA that's created or manufactured here in the United States? The answer to that is, one, most of it's corn. It's corn-based. Someone said to me, well, I drove from Texas to Florida, so all these sugarcane fields, why can't you use that? I would say the answer to that is we don't know how those workers are being treated, right? So we want to make sure that equitability is a key component of the sustainability aspect of our product. So I can take this resin and I can make a piece of Labware and you can say, well, that's great. And I can make it optically clear and biologically inert, non-pyrogenic. I can certify all that. It can be traceable. But the question is, if as a researcher, you try to do your science on that product, are there going to be any ill effects? Are there any concerns there? So what I like to say is that sustainability becomes absolutely irrelevant if it leads to bad science or compromised data. I think that's pretty clear. And when I talk to researchers, that's the biggest thing. They always look at it and say, that's nice, but what if I do X, Y, and Z? So we partnered with the NIH equivalent France, INSERM, specifically with their Cancer Research Institute. And we're 9 months into a 12-month contract to have them do comprehensive research on the product, cell growth, proliferation, morphology, solvent resistance. I meet with them every 2 weeks, and so far everything has gone very well. I'll have some results to show. And I was disappointed because right before I went to walk out the door this morning, I got a big photo dump of all the InQ site photos of cells growing on our product, which would be a lot more interesting than what I'm going to show. But so if we look at HeLa cells as an example, so this is typical of what we see, which is pretty equivalent proliferation of cells. There are some cell lines that will reach confluence much faster on our surface than on typical TC treated surface. It's not all of them. It's just some. And it stands to reason that if you were working with these cells, that your ability to process more cells would increase, right? Because you're decreasing that time to confluence. So I'm hopeful that by the end of the summer, we'll have our white paper from INSERM and we'll show all of this. And if you work on a particular cell line, you could look and see and say, oh, well, I'll be able to, increase my throughput by such a percent because these cells find the surface on plant safe to be a better surface. And this is just a quick shot of some other cell lines. The trend is what we saw in the first slide, that the proliferation is equivalent to, and in some cases better than what we see on your popular grand TC treated clates that are already on market. viability. Every cell lung that we've tested so far has excellent viability. That's something that we've seen with not only Anchorage-dependent cells, but also suspension cells as well. One of the things that I glossed over was that PLA is a hydrophilic material. It's very hydrophilic. So you're not supposed to be able to make a temperature-resistant, thin-walled, optically clear PLA part. And in the development of doing that, what we determined was that the manufacturing process, which is much more difficult than something like polystyrene, and then the irradiation process, which also has to be handled very specifically, create a hydrophilic environment that goes up exponentially. So we don't actually have to coat these. So what's nice about that is people always ask me, this is great, but how much does it cost? Is it twice as much? Is it 3 times as much? And the answer is we try to match what's on the market. So will I tell you that our plate is $1 more than someone else's? No, it's not. Is it 25 cents more? Well, that's likely. But we try to build that in and leverage that lack of need for coating. So the example I like to give on the benefit, like what kind of benefit could you see by switching to plant? Let's say, if we keep everything the same, if we just say that, okay, you're going to be purchasing it from the same distributor, it's going to travel the same distance, you're going to do the same science, you're going to, your energy usage in the lab, your lights, your HVAC, that's not going to change. But what will change between a polystyrene product and plant safe product? So if we look at the amount of CO2 equivalent per kilogram of material in the different phases that will be the same for polystyrene and PLA, we see that that's 7.4 kilograms per kilogram of material. So you're releasing 7.4 kilograms of carbon equivalent into the environment for every kilogram of polystyrene that you buy, do your science on, and then incinerate. In comparison with PLA, what you see is obviously a big decrease in those numbers, right? 2.7 kilograms per kilogram material is pretty good, right? It's a good step forward. And we can see with incineration that there's a big difference between incinerating something that's plant-based, which has biogenic carbon contained in it. So when it's incinerated, it's releasing a neutral amount of carbon dioxide into the atmosphere, and something like a polystyrene that is increasing that net total of carbon in the atmosphere. But PLA is a secret weapon, right? So what is not included in this number is the biogenic carbon. So if we include the biogenic carbon from the plant and then subtract and look at the difference. So if you were to do everything you do every single day and just switch out, say, your 9 to 6 well plate that you get from, name your, the manufacturer, and you were to use a planet safe plate and you don't change any of what you do, you have the opportunity to reduce your carbon emissions by 88%. That's by changing nothing. One of the things that we wanted to do was get to a point where we could present a 1-to-1 replacement for what's on the market, so that there wasn't going to be any operational changes of what researchers were doing every day. So that's today. We also have ASTM D6400 certification that even the 96 well plate that we make is industrially compostable. So some might say, well, that's great, but I have no way to compost it. The answer is you don't. Today, as it stands, there's no way to compost something that is Labware. An industrial composter will not take it. It's not yard waste or yard waste adjacent. It's not food waste or food waste adjacent. But I'm hopeful that every Planet Safe product that's branded, labeled Planet Safe will be industrially compostable, so that when we have the opportunity to work with facilities, we'll know that they'll be successful in processing the materials. And you might say, well, that's great, but it's biohazardous waste. What do we do? And I always paint this sort of magic carpet ride picture of, if we talk to our friends Renova or Ion Systems, these are companies that have equipment where you can take your Labware, you can put it in. In the case of Renova, you can wash it at room temperature. You have something that, couldn't be considered sterile, is perfectly reusable. It's decontaminated. You can use it again. Ion field systems, similar process, but they add into it a plasma treatment as well. So we can envision a system or a workflow where you buy Planet Safe, you use it. When you're done, you put it into your Renova machine or your ion field system machine. and you use it again. I'm more about the environment than I am about Labware, right? So use it again and use it again. Use my single-use plastic, my single-use Labware over and over again. And then the last time you put it through the machine, go over to the Plan Safe bin that we are, we partner with Polyparty now. Go over to the Plan Safe bin and throw your product in there. That product gets picked up. It goes back to the manufacturer, and it gets hydrolyzed, and it gets incorporated into their 100% recycled resin offering, which does exist. And I'll point it out here. So one of the really cool things about polycarbonate, one of the really cool things about Total Energy's Corbion, like I said, is they're visionaries. So they've actually, not only do they keep their LCAs up to date, but they also have an LCA specific to the 100% recycled material. So if you are going to use resin that is 100% recycled through their advanced recycling process, you're starting with something that's actually carbon negative. And that's not a number I made up because it sounds cool, or I thought, well, it's probably what it is. They actually have third-party verified data that says their 100% recycled resin, at the time it is manufactured, you're starting with a carbon negative footprint. So in the future, when that exists, we'll be ready. That's something that we can then take, incorporate into our products. And as you can see, we've even increased the impact. Planet Safe will always be transparent. Planet Safe will always be certified. That means everything that you see here. So we know that if you were to compost Planet Safe and plants were to grow there, it's non-phytotoxic safe. We have our biobased product certification. I do everything with Planet Safe, so it's not there yet, but I am working on an LCA specific to our products in the background. And of course, when that's available, that's something that we will be very, very forward-facing about, present to everyone. So with that, here's our family, soon to include flasks, and that's it.